Alright, so number 69 says determine the amplitude period of the function and graph one period. So for 69 we've got y equals negative 2 the cosine of 2x. That has an amplitude of 2, and the period is 2 pi divided by b, and b in this case is 2, which means the period is pi. Okay? We've got a cosine wave and it's negative, so there's no vertical shift, which means the midline is still the same, and the amplitude is 2, so up 1, 2, down 1, 2. Graph it like that. Our amplitude lines. Period is pi, so I'm going to go 1, 2, 3, 4. I'm going to let that last one be pi, which makes this one half pi, 1/4 pi, and 3/4. 1/4, 2/4, 3/4, 4/4, right? It is a negative cosine wave, so it will start at the minimum midline, maximum, midline, minimum. And so your wave should look something like that. Okay? Number 71 is y equals 1/2 sine of pi over 3x. So that is a sine wave with an amplitude of 1/2 and a period of 2 pi divided by pi over 3, which is 2 pi times 3 over pi, which is just a period of 6. Okay, so that can be whole number periods. It doesn't have to have anything to do with pi. Okay, so 1, 2, 3, 4. And I'm going to let the fourth tick mark be 6, which makes this 3, which makes this 3 halves. And if that's 3 halves, then that's 6 halves, and that's 9 halves. Okay. The amplitude is just 1/2. So if this was 1 and this was negative 1, then we would be going only up a half and only down a half. It is a sine wave, and sine starts at the midline and then goes up. Midline, minimum, midline. So this is a sine wave, period of 6, an amplitude of 1/2. Okay, 73. 73 is y equals 3 cosine of x over 3. That has an amplitude of 3 and a period of 2 pi divided by 1/3, which is 2 pi times 3, which is 6 pi. Okay, so similar to number 71, its period is 6 pi as opposed to 6, but the fractions will still be the same. So I've got a cosine wave, the period of 1, 2, 4, a period of 6 pi, which means this is 3 pi, which means this is 3 halves. So 3 halves, just kidding. 3 halves, 6 halves, 9 halves, and 12 halves. Okay? You've got 1, 2, 3, 1, 2, 3, amplitude of 3, which means we go up 3 and down 3. It is not a similar scale. Sorry, I want to fix it. So closer. So up 3, down 3. And your cosine wave starts. Because it's a positive cosine wave, so it starts at the max, midline, minimum, midline, max. So your cosine wave in general, that's definitely not the same scale. That's terrible. Oh well. And there you go. Okay. Number 75. Y equals negative 3 cosine of x plus pi. So it says determine the amplitude, period, and phase shift. So amplitude is 3. The period is 2 pi divided by b, and there's an understood 1 in front of the x. So that's 2 pi divided by 1, which is just 2 pi. And then phase shift is just negative c over b. Negative pi over b, which is 1, so we're going to the left pi. Okay. So I've got a cosine wave. I've got just one period of it. So the period is 2 pi on my graph. 1, 2, 3, 4. That'd be 2 pi. I'll let this be pi. This be 1/2 pi. And 3/2 pi. 1, 2, 3, 1, 2, 3. So my amplitude is 3. And it is a negative cosine wave. Negative cosine waves start here, go there, maximum, midline, minimum. Yeah. So that is my that's my negative cosine wave without the phase shift. And then the phase shift says go to the left pi. So pi is 2 tick marks, which means half the wave. So if you start from the right, this point will go here. This point will go here. So that's enough for me to go ahead and be able to sketch the rest, because I know I'm going to go from there to there, from here to there, and from here to there. And so you should see that. Now, I'm obviously graphing from 0 to the window. If you took this wave and you just moved it over and just had it symmetrical on either side, that's absolutely fine. That is one period of it. So there's no like right or wrong on this one. It only says graph one wave, one period. Okay. All right. That's just how I'm doing it. 76. So 76 says, oh, I don't know what I did. 77. Okay. So 77 is y equals 5/2 sine of 2x plus pi over 2. So I know that I've got an amplitude of 5/2, a period of 2 pi divided by b, which is 2, so a period of pi, and a phase shift of negative c over b, which is 2 over 1, which means multiplied by 1/2, right? So that means I'm going to go left pi over 4. Okay, so we've got a sine wave. 1, 2, 3. 1, 2, 3. Okay. Period is pi, so I'm going to go 1, 2, 4 tick marks, and let the last one be pi, which makes this a half pi, which makes that 1/4 pi. 1/4 is 2/4, that's 3/4 right there. Once you get the first tick mark, you just count it up. Okay, the amplitude is 5/2, which means goes up, go up 2.5 and 2.5, and down 2.5, 1, 2.5. Okay, it is a sine wave in a period of pi, so I'm going to graph just a regular sine wave with a period of pi. And then I'm going to perform the transformation. So if you can just jump straight to the transformation, go for it. Alright? So you know that you're going to graph a sine wave and then go to the left pi over 4, which is 1/4 of it. So this one goes right here. This one goes right here. This point goes here. That point goes there. And then you got one more point, that one right there. So it actually just becomes a cosine wave. Alright. 78. So 78. I'm doing that one, right? Yep. Alright. Equals -3 sine of pi over 3x minus 3 pi. Then amplitude of 3. I've got a period of 2 pi divided by pi over 3, which is 2 pi times 3 over pi, which is 6. And I've got a phase shift of negative and positive, sorry, negative c over b, which is pi over 3, which means multiply by 3 over pi, which means I'm going to go to the right 9. Okay? Now 9 is a period and a half. Since 6 is the period, that means go right a period and a half. But if I go right a period and a half, I might as well just be going to the right 3. But I'll explore that with you for a second. Oh, that's so much better. Okay, so I've got a sine wave and amplitude. So 1, 2, 3, 1, 2, 3. Okay. It is a period of 6, so 1, 2, 3, 4, and then it is 6, which makes it 3 halves. 3 halves, 6 halves, and 9 halves. And that's 12 halves. Always check to make sure that it makes sense for your period as well. Okay. And then, okay. A regular sine wave is a negative sine wave. Starts here, goes to midline, or minimum. Midline, maximum, midline, right? So that's my wave without a transformation. And then it says go to the right 9. Okay. So if you go to the right 9, you just continue on what you're saying. This is 3, 6, every other 2 3, so that's 9. Okay. So if I take this point and move it here, right, then that would mean it would look like this, right? And so you can see how that is basically just mimicking this, which is just taking this point and moving it to the right 3. So might as well just take everything to the right 3. This is right here. It's not 3 check marks, but 3 on the scale, right? So then this goes here, and that's enough. So I know that this will be here, this will be here, and that will be there. And there we go. Okay. So, or 80. Okay, so 80 says use vertical shift to graph one period of the function. So 80 is y equals 2 cosine of 1/3 x minus 2. Okay. So amplitude is 2. Oh, just kidding. 1/3 x minus 2. Okay. So my midline, it says go down 2, and my amplitude is 2. So I'm going to go down 1, 2, 3, 4. So the new midline is -2, and my amplitude lines are 2 up and 2 down. So at -4 and 0. Okay. I'm going to go ahead and mark those for 1, 2, 3, 4, which means down here. And I'm going to cosine wave with 2 pi divided by 1/3, which is, I really like this number, 6 pi. So if this is 6 pi, and this is 3 pi. 3 halves pi, 3 halves, 6 halves, 9 halves. Okay, we got a cosine wave, so cosine starts at the amplitude. The max comes down, minimum, midline, max. And then there you go. Okay, all right, I'm gonna go to another page. So number 81 says the function y equals 98.6 plus 0.3 sine of pi over 12x minus 11 pi over 12. Models variation in body temperature in degrees Fahrenheit. So y is degrees Fahrenheit and x is in hours after midnight. After midnight. Okay. So let's figure out the period and all that, right? All right. The 98.6 in the front, it might as well just be plus 98.6 right here. So if you think about that, we're talking about what your temperature should be, 98.6, and then a slight variation in that, right? So we're going to kind of draw an x or a y. We're going to let this be the x-axis, yeah? And I'm going to let 98.6 be right here on the y, with a variation of down 0.3 and up 0.3. So down 0.3 would be 98.3, and up 0.3 would be 98.9. So let's go to midline, and we got amplitude. Okay. Let's talk about period. Period is 2 pi divided by b, which is pi over 12. So divided by pi over 12 means multiplying by 12 over pi. So the period is 24. Now, remember, x stands for hours, so this is 24 hours, which makes sense. We're talking about an entire day. So this time right here is 0 hours after midnight, so basically midnight. And then 1, 2, 3, 4. So that would be 24. So that would be midnight the next night. Noon, 6 a.m., and we'll go with 6 p.m., which is 18 hours after midnight. Okay, so this is a sine wave and a phase shift. So phase shift is negative c over b, so plus 11 pi over 12 over pi over 12 means 11 pi over 12 times 12 over pi, which means 11 hours. So we're going to shift it to the right 11 hours. So I'm just going to kind of draw a sine wave right quick. So say I've got a sine wave, and this right here is 24, and this is 12, and this is 0, right? What that tells me is that 0 would be at 11, because I got to go right 11 hours, right? So that's kind of ugly, but there you go. So this would be at 11. So 6, 8, 9 in the middle, 10, 11. So my mid, that would be right there. Yeah. 12 plus 11 would be 23, so that would be, so that's 21, 22, 23. So 3 right here. So that's at 11. This is at 23. This right here, this maximum is at 6. So 6 plus 11, that would be 17. So 13 there is 15, 16, 17. So the maximum would be at 17. And this this minimum, well, the previous minimum, right? So the previous, well, it's just, I mean, honestly, there's just like 6 up here, right? So plus 6, so I go backwards 6, 7, 5. So 3, 4, 5, so 5. Right? Okay. So just kind of a basic sense of what's going on. Now, if this is 5, then the next midline point would be at -1, so at 11 p.m. So we'll just kind of pretend like we're coming from there, right? And then this will just kind of go. Okay. Awkward, but there you go. Now, you probably didn't have to do, especially if it's a calculator question, which I haven't decided whether or not it would be, but I don't think you need to, because I think you can just answer the questions without all that. So let's just figure it out. What you looking for? Okay. Yeah, I've got a teal one. So if you want to use that one, just go over the original page numbers right now. But same thing. Okay, so A. What is the body's temperature at midnight? At midnight. Okay, so I guess calculator question. You would just plug in 98.6 plus 0.3 sine of pi over 12. Midnight is 0 hours, so times 0 minus 11 pi over 12. And type it in. We do want to make sure that we are in this case, degrees. It said, oh no, I need to be in radians because of the pies. Okay, so 98.6 plus 0.3 sine of 0, right? Because it's pi over 12 times 0 minus 11 pi over 12. And you get 98.522 degrees. Okay. Now, I just explored all that without a calculator, but if this is a calculator question, could you just graph this and just said, okay, 98.6 plus 0.3 sine of pi divided by 12 x minus that 11 pi divided by 12. And if you go Windows 0 to 24, and let's just go, I'm gonna go, since my window is 90, on the Y, we're going from 98.3 to 98.9. I'm gonna go 98.2 to 99. And we'll do a scale of 0.1. And so you can see how that mimics the graph that we had right there. Okay. All right. So could I then have just, well, okay, you could just go second calculate and do value at midnight, which is 0, and they would tell you 98.522, right? Okay. Part B. What is the body's temperature? What is the period of the body's temperature? The period would be 24 hours. C. When is the body's temperature the highest? The body temperature is the highest at, let's see, 17 hours after midnight. So if you just think midnight and then plus 5 hours, then that is at 5 p.m. So 5 p.m. is when it's at its highest, and that is at 98.5 degrees Fahrenheit. D. Body temperature is lowest at 5 a.m. Which you can see right here. So if you did second calculate max, I know it's between, I know it's at 17 hours, so let's type 15. And it finds the maximum to be at x equals 17, which is 17 hours after midnight, or 5 hours after noon, and then and you find the minimum the same way. So 5 a.m., and that is at 98.3 degrees. And then E, graph on period. Okay, I know. So there we go. Okay. 82. Light waves can be modeled by sine functions. The graph shows waves of red and blue light. Write an equation and the models each of these. Okay. So you can see that our answers are correct for that one. Okay, 82. Light waves can be modeled by sine functions. So, for the red one, what I'm seeing is that, let's see, that's 120. Let's see. Okay, these tick marks, let's 120 divided by 3 is 40, so let's see if that makes sense. 40, 80, 120 plus 40 would be 160, 160 plus 40 would be 200. So I'm thinking each of these tick marks is 40. Okay, so if I'm trying to find the red wave would be 640 for one period, right? So sine wave with a period of 640. So blue. Period equals 640 nanometers. As far as height goes, it looks like it only just goes up to 1. And so, yeah. Okay. Goes up to 1 and down to 1. So, really, for blue, you got y equals sine of, so 2 pi divided by b equals the period, which is 640. So if you divide by, or you multiply by b and divide by 640, 2 pi divided by 640 equals b. That is 320. So pi over 320. Pi over 320 x. And there you go. And then for red, we've got, just did red. Damn it. This is being ridiculous. Red is a period of 640. I'm sorry. It's kind of ridiculous. Okay. Red has a period of 640. Blue has a period, let's see. Blue stops here. So 40 away from 520, 480. Okay. And still amplitude 1, negative 1. So blue has a period that is, what do I say, 480. Okay. So 2 pi divided by b equals 480, which means 2 pi divided by 480 equals b, which is just pi over 240. So y equals sine of pi over 240. And there we go. Sorry, so negative. Okay. 84. 84 says, graph two full periods of the given tangent or cotangent function. So y equals negative 2 tangent of pi over 4x. Okay. So, sorry, I had to take a break from my video because I'm looking at all these calculus kids working so hard. It's so great.
Is the video still going?
Yes.
Can I talk to him?
Sure. And we're going to take a break for a message from, do you want to say?
Yeah, hey guys, it's Gary Meadows. I just want to say, take calculus, A, B, or B, C. It doesn't really matter. Take it. It's worth it. It's extremely hard.
Okay. And back to your regular program. Although I do agree with him. Yes. Unless you just really don't need it, in which case, don't do it to yourself. Okay. So, tangent. We've got an vertical stretch by a factor of 2. It's a negative, so it reflects over the x-axis, and period. So remember that tangent and cotangent only have a period of pi. So when I find the period, I say pi divided by b. Pi divided by pi over 4 is the same as pi times 4 over pi, which is just 4. Okay. So I've got the tangent. Now what we hopefully remember is that when you graph tangent, you always think, okay, I always make them just two tick marks, not 4 like sine and cosine, right? I let half of the period be on this side. So I'm going to make this -2 and then half the period on this side. And then make that +2. Because tangent is symmetrical across the y-axis. So that means every tick mark is 2. So the next tick mark would be at 4, and that would be a center point. And then the next tick mark would be 6. Third class it took. Okay. So I need a scale on the y. 1, 2, 1, 2. Alright, so normally tangent does this. But because it's negative, it's going to come from above and go down. So we're going to come from above, but we need to go through these points because it is 2. I need to go at this half mark at -1. I need to be up here. And at +1, I need to be down here. Again, at 3, I need to be up here at 2. And at 5, I need to be down here at -2. So I've got my midpoints and my midline, my zeros, I should say. And my graph. So you can like this. It comes down, goes through. And there is my tangent wave. Okay. So 85. 85 is y equals tangent of x plus 5. So when you think about this right here, it's kind of a silly graph. Period is pi over b, which is just 1, so it's pi. Okay, and then the phase shift is -c over b, which is -pi over 1, which is just -pi. So the period is pi, and then I'm going to go left pi. You're literally going to go left the period. It's going to change the same spot. So x and y. So I need 2 periods, right? So normally tangent has a period of pi, which means half pi, -half pi, right? So that's half pi, then that's pi, and then that's 3/2 pi. And then it does this. Yeah? Well, if you go to the right pi, or left pi, so this point right here at pi is now going to go here, which is the exact same thing. Okay? So we're basically just graphing a tangent. As long as we have everything right. So, this would be half pi, this would be -half pi, this would be pi, this would be 3/2 pi. 1/2, 2/2, 3/2. Here, it's a normal tangent, so left only left a quarter of the period, and go down 1, right a quarter of the period, go up 1. And then again, and there you go. Okay. Let's see. 88. So 88 says we're going to graph y equals -1/2 cotangent of pi over 2x. Okay. So if tangent is symmetrical about the y-axis, cotangent is basically you start at 0 and then you go to the period, just like kind of sine and cosine. But you got to remember that period is still only half of sine and cosine's period, which is only pi. Okay. All right. So 1, -1. Period is pi over b, which is pi over pi over 2, which is pi times 2 over pi, which is just 2. So the period is 2, which means we go 1, 2. So there's no phase shift, so this is limitless. 4. So let's graph 2 periods. So I know that cotangent always has a vertical asymptote at 0 in its period. And we're doing 2 of them, so there we go. My points that I need to cross at are here, midline always, But it also has that negative and then 1/2, right? So normally a cotangent wave does this, with that being a period and 0, right? It being negative means it's actually going to start going down below, which means when I go left a quarter, I need to go down 1/2 because of the half, and then when I go right a quarter, I need to go down 1/2. So left down, left, right, 1/2. Which means my final answer is like that. All right, 90. 90 is graphing 3 secant of 2 phi x. Okay, so we got a vertical stretch by a factor of 3, and then the period. Secant is reciprocal cosine, which means we go back to the normal period. 2 phi divided by b, which is 2 phi, which is just 1. So, the cosine wave. This is graph 2 cosine waves. So, 1, 2, 3, 4, 6, 7, 8. So, if 1 is my period, that's 1. That's 1. 4. 3 fourths, 4 fourths. That's 5 fourths. 1/2, 2 halves, 3 halves. Oh, I see. 3 fourths. Oh, I started doing it again. 5 fourths. 6 fourths is 3 halves. 7 fourths.
And
8 fourths, which is 2. Okay. 2, 3. So, if I were to graph a cosine wave, so I can graph my secant. The cosine wave normally starts like this, and so at the period I should be back on x. The cosine wave does this. Crosses here, and then goes up here, and then crosses here, and then maximum there. But we're trying to graph a secant wave, and secant has a vertipositive every time cosine is 0. So I know that is up here, down here, up here, down there, and this part right there. And that would be 2 full periods. Okay. And I'm going to stop this video and then start another one for the rest, okay?